Hi, and welcome to a tutorial on visual scripting for Unity. In this tutorial, I want to focus on the absolute basics of what it takes to work with visual scripting, some of the core concepts, and how to make a very basic mechanic within a scripting graph. Uh, this is in service to the goal of showing you how I have, through a series of tutorial videos, showing you how I have used visual scripting to build pretty much the entirety of a video game from the ground up. A quick backstory. So, I am not a technical person. I am not a software engineer. I'm not a software developer. I can barely read a line of code, let alone write something like C sharp. And that was constantly a barrier for me, despite the fact that I had a lot of passions and a lot of imaginations that I wanted to bring to life. There's a world in my head that I just it begs to exist. And for the longest time, I thought that it would just stay in my head because I couldn't really bring the universe to light through writing or through art, despite being a writer and an artist. And it's just kind of hard to gain traction in that market. And so I wanted to turn to video games, but I didn't have the technical skills. That was at least until I found visual scripting, and that kind of unlocked a lot for me. It's worth mentioning that everything that you've seen so far has been built entirely with visual scripting in Unity. I haven't had to write a single line of code. Now, that's not technically correct. I've created some scriptable objects here and there, but more or less 99.9% of everything that I've built so far has been with visual scripting. And I'd like to use this video tutorial series as a way of potentially inspiring somebody else who might be like me to give it a try, and perhaps you can be unlocked to kind of realize and manifest your vision as well. So without further ado, let's go ahead and dive in. I want to kind of show you the basics in a script graph of what visual scripting has to offer, and then let's go ahead and just create a very basic mechanic of something like a gold spawner, or something that spawns little gold tokens periodically for the player to pick up. So let's go ahead and create a empty game object, and I'm going to add a component, and I'm going to add a script machine. Now, right out of the gates, this represents, uh, you know, two of the most important components with regard to visual scripting: the variable component and the script machine component. Variables are what you would expect. They store information. So, for example, we could store a variable called name, give it a type like a string, and then call it something: gold spawner. Now, this doesn't really do anything by itself, but let's actually proactively uh, enter a new variable called frequency, store that as an integer, which is a whole number, and just say, I don't know, 5. We'll use these values in a moment, but the idea is that these values, these variable names and their associated values, can be referenced and pulled and modified within the contents of your script machine. Now, script machines are the actual graphs that allow for visual scripting. So let's go ahead and create a new graph now. I'm just going to call this test gold spawner. Spawner, just for now. We're not going to really use this in the game. This is just for the tutorial. When I click Edit Graph, that automatically opens up a window where I can see the graph, and I can move little nodes around. I'm going to go ahead and delete these for now. And I'm actually going to kind of open up the Node Explorer. The basic idea here, or the core concept within this graph, is that you can construct a series of nodes and string them together through flow logic in order to make things happen in the game. Now, I've actually just deleted two of the most important node types, which are event nodes, and I want to talk about event nodes now. So under the kind of the menu tree, we see events, and we see a lot of items usually highlighted in green. This isn't, I think, an absolute rule, but most events are colored green, and events are initiating, blocks of logic that begin a series of logic. And let's go ahead and actually start with the start node. So start. So onStart is an event node where at the very big, when this unit is either first created or at the loading of this scene, this series of logic gets initiated. And we see that there is an arrow here in the output section of this node. This, you can drag this little flow line. I actually don't know the formal term for this, so I'll just call this the flow line for now. You can drag this into another node that has an input that would receive it. So let's actually create something like a, let's do a set variable node. So we have a lot of variable types here. I guess this is a good opportunity to explain very briefly the different variable types. I primarily work with object variables. Object variables are variables that are stored on the object itself and are defined here. Now, if we click within the graph, we can see different variable types available on the left-hand side as well. If you don't see this, try messing around with the options up in the top or left, or the top left-hand corner of your graph. There are graph nodes, which are variables that are only accessible from within this graph. There are object nodes, which are available for any script machine or script graph that has been added to this object. For example, if I wanted to create another script somehow, it would be able to reference that same list of variables. And then there are scene variables, which are defined within our scene hierarchy. Right now, we're only going to be focusing on the variables on the object just for the sake of simplicity. So when we drag in the flow logic, or the flow line into the input for the scene variable node, that essentially communicates to our script that when the game starts, we want to set a variable. Now, this is a good opportunity to kind of talk about the anatomy of just kind of like a basic or a normal node. In this case, this node is a node that is going to perform an action for us, specifically creating or setting the value of a variable. It has a set of inputs on the left side of the, node, and then a set of outputs on the right side. Now, in some cases, especially for the inputs, it's possible to define default values so that you don't actually need to drag any values into these. Otherwise, you usually do. So for example, for this variable, we can simply select from the dropdown one of the object variables that we've already defined above. So here, let's go ahead and actually select the frequency variable, communicating to this node that we want to somehow change the value of frequency. And we are saying that we want to do so in this object. And then we need an input value. Now, this input value we need to define from some other get node. And let's say, just for the purposes of this demo, I want to introduce you to a get node that allows us to get the value of a random value. I use this a lot. So let's do random range. And we can choose either a float or an integer. A float is a value that can have a decimal in it. An integer is a value that is going to be a whole number, 0, 1, 2, 3, 4, etc. So let's go ahead and use a float. And just for the sake of this demo, let's go ahead and say 5 and let's keep it short. Let's go 3 and 5. Now, this is telling us that we want to get a value between 3 and 5. When we drag and drop this output into this input, what we're communicating here is that we're going to be setting the frequency variable in this object to a random value between 3 and 5. Now, that's going to be in service to defining the frequency, which will allow us to move on to the next step here. So another node that I use quite often is the timer node. So this timer node has a lot going on, but I only really usually use a few items here. There is the start input, as well as pause, resume, and toggle. Now you can imagine lots of logic being useful for, of course, starting a timer, but then somehow under some conditions, somehow pausing, resuming, or turning it off and on. I primarily use start. And we have a duration input and an unscaled input. Unscaled really only communicates whether or not a timer is going to be active when the game is paused or when the time scale is set to 0. For most gameplay, I set this to disabled or this Boolean unchecked because if we're spawning gold and the player is paused, I don't want gold to continue spawning. We'll leave this unchecked. Now the duration is what we actually created this frequency variable for. Now we have two options. We can either drag the output of this variable into this input, or we can get the value for a variable. Now for the sake of this demo, I'm going to do the latter. So let's go ahead and search for the get object variable node, select frequency, and when we drag the output of the get object variable node into the duration value here, what we're communicating here is let's start a timer for a duration set to the frequency. Now previously we set the frequency to a value between 3 and 5. Now this one is a little bit tricky, or the next step is a little bit tricky for that, for creating a gold spawner, but I'm going to drag this and create a sequence node. Now, sorry, before we go there, let's discuss the outputs for a timer. So once again, similar to lots of different input options or input flow options, there are lots of output flow options: started, tick, completed. These do kind of what you would expect. The moment that timer started, if there's anything associated or attached to the started flow, then that line of logic will be initiated the moment this timer started. Similarly, for tick, every frame that this timer is active, something is going to, or I guess for every tick or every frame that this timer is active, this line of logic would be initiated. This is very, very useful for, say, moving an object towards its destination or something like that. For the completed flow, the moment that, or the frame that this timer runs for its duration, this line of logic will be executed once. And that's what we want. We want to drag this into a node that will allow us to do two things. And if we want to do two things within a set of logic, we use the sequence node. Now, the sequence node doesn't really do anything by itself, but it allows us to fork our logic so that we can accomplish more than one thing within a line of logic. In this case, I want to do two things at the same time. First of all, I want to actually restart the logic. So the moment this timer is completed, I'm going to go into the sequence node, and the first thing that I'm going to do is I'm going to restart the timer. The second thing that I want to do is I actually want to create a gold coin, which I will drop on the ground. Now, I've created a prefab for that gold coin elsewhere, so we don't need to worry about that too much, but we do need to create a instantiate game object node. Oops. Instantiate game object node. Now, at this point, it's probably worth mentioning that there's lots of different flavors of different actions that you can take. In this case, we're just going to be selecting the version of the instantiate game object node that requires you to define an original or a prefab, a position, and a rotation. Now, this node, instantiate game object, allows us to create new objects from prefabs in the scene. And to do so, we need to define what the object is that we want to create. We need to define the position where we want to create it, and then we need to define the rotation by a quaternion. In most cases, the quaternion or the rotation can simply be a quaternion literal of 0, 0, 0, 0. I recommend, as beginners, you just avoid any intimidation about the complexities of what this is. When you need to learn this, you can, but that is at least intermediate, at least for me. The position is a value associated with a transform, which every game object has, and consists of an x, a y, and a z coordinate. A x, a y, and then a z coordinate being effectively up and down, or directly towards the camera and away from the camera. Now, what we want to do is we want to define where this is going to come from. And in order to do so, I'm going to recommend that we actually create a new object. Let's call this spawn. Oops. Let's create a real-looking variable. So spawn point. I'm going to make this a game object type, and I have to create a game object for that. So I'm going to create an empty object as a child of our gold spawner and call it spawn point. So now our gold spawner has a spawn point, and just for the sake of visualizing it, I'm going to give it a sprite renderer. Now, this is not the right demo. Circle for learning about sprite renderers or anything outside of visual scripting. If you're interested, please let me know and I can help you understand more details about that. But just for the sake of this demo, we're going to drag this object over here. Let's color this red. Let's color it gold because that's the color of gold. And this is going to be how we identify the point at which, or the object at the point at which we want to spawn gold. Now, you might be wondering, we could have also very easily defined a, let's say a spawn point position variable using a vector3 variable type, and then manually filled out the values here, using whatever values would have been in this range. That's totally viable. That's an absolutely valid way of going about it. Sometimes I just prefer to use objects so that if I change my mind about a position at some point in the future about where I want something to be, I can quickly drag and drop it without having to go back over my work. So I'm actually going to delete the spawn point position, but just keep in mind that that's a valid option as well. All right, so we have a spawn point position, which is different from our gold spawner. Oops, it looks like it's the same as our gold spawner. Let's make sure that it's different. Oh, let's create a sprite render on this object as well, just so that we can make sure that we can see the differences between the two. There we go. That should be sufficient. It's really, really ugly. Let's my OCD is kicking in. Let's try to find somebody to fill this in. So let's all right, a really big scoundrel. We're going to set you just to 0.5 just to make you look like a reasonable person. All right, so we now have a scoundrel who's just kind of lurking at the corner of this market, throwing gold coins at you. Not sure why that's happening from a narrative element, but it at least looks a little bit better. Okay, so let's go ahead and get back into our script graph where we've defined, we need to drag and drop the spawn point object into the value of the spawn point variable. So now that we've defined that variable as an object variable on our gold spawner object, we can come back into the graph, the script graph for this object, and we can tell our script what we want to do when we want to spawn a golden coin. So first of all, we can make a reference directly to a gold coin or a prefab of a gold coin that I've created elsewhere or previously right within our graph. So in this case, let's go game object literal. And this allows us to search for one of the assets that we've created already. So let's search for gold. Here we go. This is my gold coin. This is the object that I want to instantiate or create every so odd seconds between 3 and 5 seconds. Now, I still need to define the position, and what we've done is we've created a spawn point game object, which references another object which is at the position that we want to create gold coins for. So I'm going to get object variable, which allows me to get the value of some object. In this case, I want the value of the spawn point, which will, as an output, produce or provide me with a game object. And then I want to find that object's position. Now, it's helpful to know that a game object has a transform and a transform has a position. But if you were poking around for the first time, you might not know that. But you should know that the spawn point is at least a game object, and there's a very handy type or series of nodes which are called expose nodes. You can expose a game object, you can expose a transform, and that's exactly what we're going to do here. So we're going to drag this and search for expose game object. And this is a handy cheat sheet that allows you to get the components, for lack of a better term, or values from a given object. In this case, we can walk from the game object itself, the spawn point game object, to the transform, and we can drag the transform into a new node, expose transform, which itself has many other values, and we see the value that we're looking for, which is a position. The position output here maps up to the position input, and what we are now communicating through this node is that ever so often we want to instantiate a new instance, or we want to create a new instance of a gold coin prefab at the position of this object's transform with a rotation of 0, 0, 0, 0, which is unaltered. Okay, so that should work. Now, let's do a couple things that will make this look a little bit better and will help showcase some of the other nodes that I use quite frequently. So on start, to explain that, this little yellow dot is very handy for me as a developer, but it's not very appealing when it comes to gameplay. So let's go ahead and make it disappear when the game starts. So I'm going to break my flow here and create a new node called set active, or game object set active. I'm going to drag my flow in and out of here so that the chain of logic continues through it. And within this set of logic, I'm essentially saying I need an object, or this is essentially saying that for the object defined in this node, I'm going to set it either to disabled or enabled, or active or inactive. And what we want to do is we want to set this object to inactive. So I'm going to, once again, get object variable, and I'm going to get our spawn point object itself. I'm going to drag this into the game object input for the game object set active node, and I'm going to keep this value as false. Now, I could create a Boolean literal input and drag that in, or I could get a variable called, I don't know, just false. That is a Boolean type set to inactive. And then I could get object variable. I could get that variable or the value of that variable and drag it in. There's lots of ways to do this, but this is the most direct. So what this is doing is essentially the moment that the game starts, for the first frame that the game starts, I am, in addition to all the other logic, I am disabling or setting this item or this object to false. Now the good news is that we can still get the attributes of that object, even when it is in a disabled state. It will still have a transform, it will still have a position, and we can get that value, but it won't be apparent to the user or the player. Okay, so to rerun through all of that very briefly, we have a start event which initiates a set of logic that's connected through the flow chain here that sets the frequency variable to a value between 3 and 5, somewhere in between that value. We are disabling or just disabling the spawn point object, which we've defined in our object variables. And then we're starting a timer set to the frequency that we defined here. And every time that this timer resets, we are creating or instantiating a new game object at the location of the spawn point. So let's go ahead and run the game and see how that works. Now, while this is coming up, it'll take a second to load. I do want to say that I'm not trying to impress anybody with the state of the game right now. I'm currently demoing out of a test scene, which is very much under development. This is really just in service to the goal of showing how I do things. All right. And once again, there is a lot of placeholder logic here. All right, so we spawned in. This is the testing ground for the Waking of Haven, and here we see that our little scoundrel is spawning gold at the location that we previously told him to, and the actual spawn point doesn't appear anymore. And so every couple seconds we see a coin pop up. Now, just to show you what's kind of going on under the hood, let's go ahead and look for the object that we created. I'm going to go ahead and pause the game real quick. Where is our object? Here it is. There's the gold spawner. And if we open up while the game is running the script machine, we should be able to see the logic as it flows. So we have previously executed this line of logic, and now we have a timer that's essentially running in perpetuity that will every, I believe this is 4.88 seconds, will be, why is this 5? That's interesting. I believe that's a visual error. This should be 4.88 seconds as defined over here. That should be instantiating or creating a gold object, and we can follow the chain of logic. We can follow that chain of logic by following these little kind of heartbeat pulses. This is especially useful for debugging your code in case something is going wrong. If something's going wrong, you can always pull this up and take a look and see where your logic is failing to continue through the set of logic that you intended. And oftentimes you'll be either missing a variable or missing an input. In fact, let's go ahead and see if we can mess with this in order to trigger an error. So I think I want to go ahead and let's get another object variable here. So let's do get object variable. Get object variable. And I want to show you how the visual scripting breaks in ways that are very easy to debug. So if we create or we get a node that gets the frequency variable, and then if we swap out the inputs for the game object prefab, the next time this runs, we'll see a red error pop up. And that's because this node is expecting a game object prefab as an input, but instead we're trying to feed it a integer as an input, and that doesn't work. And we'll get a very unfriendly little notice saying that we can't convert a integer into a game object. And that's a handy hint that helps us understand what we did wrong and allows us to fix it. We can reconnect, and the next time this runs, we should see another coin pop up. There we go. There it is. All right, let's go ahead and scoop up all these coins. Boop. There we go. All right. I think that concludes it. I hope you enjoyed. If you would like to see any specific tutorials, please let me know. Otherwise, I did get a request for projectiles and movement, which are my current next 2 priorities. It is worth mentioning that my voice is hopefully a lot more clear than past videos. That's because I've been working over the last month to try to get a mic that actually works, and now I'll be able to kind of jump back on track with regard to sharing progress updates. So yeah, thank you so much for watching. Any feedback or any special requests would be highly appreciated. I hope you have a wonderful day, and I really do hope that somebody is out there who's like me, who is fundamentally an artist, limited by your technical expertise. I hope you're listening. You can do this. You have the abilities. Anyone can. I believe in you. Have a great day. Have a great night, and I hope to talk to you soon.